Hey guys, so I didn't think an email was actually the most helpful thing to learn about partial pressures and pressure gradients. So I'm creating this video in the hopes that it does help you out more, and let me know if I misspeak, excuse the mess, etc., etc. So let's just get started. First things first, this is just a little bit review of information to make sure we're on the same level. 760 millimeters of mercury is actually the combination or the sum total of the pressures of all the other gases that contribute to atmosphere air. So of all of them, nitrogen and oxygen make the most contributions. Nitrogen makes up 79% of all of atmospheric air. So what you end up doing is take that percentage and you turn it into a decimal. You multiply that by the atmospheric pressure, and then you get the actual pressure that that gas exerts. So when we're talking about nitrogen, that's how much, and when we're talking about O2, we're talking about 160 millimeters of mercury. So that being said, let's talk about respiration. So atmospheric oxygen is 160 millimeters of mercury. When we breathe, we actually mix it with water vapor, just because that's what's going to help us be able to inhale better and faster. Water vapor exerts its own pressure, and it's about 47 millimeters per mercury. So what you're actually doing is diluting oxygen when you inhale it and mix it with water vapor. So you actually decrease that pressure to 150 millimeters of mercury. Okay, so then from here, once it goes a little deeper into the lungs, actually right into the alveolar sac, the alveolar sac is where the arterioles actually are. You're actually diluting it even more because the arteriolar sac has a ton of other oxygen, other gases in it, such as CO2, and etc., etc. So the alveolar sac represents a site of more dilution for this air. So we start at 160, we go down to 150 with water vapor, we go down to alveolar sac and it dilutes more, and it actually goes down to 100 millimeters per mercury. So that's the alveolar partial pressure of oxygen, right? So here's what happens. Systemic circulation depletes the oxygen levels in the hemoglobin, right? So when it goes back into the heart and into the pulmonary artery, we actually have the oxygenated blood to the lungs, but the oxygenation doesn't mean like the partial pressure is 0. It actually means that partial pressure is 40. Not sure 100% why yet. We can talk about it another time. So partial pressure is 40. This represents the oxygenated blood. I know it's not 0, it's 40. 40 is partial pressure of oxygen being 40 is the oxygenated blood. Understand that concept. Okay? So what happens is at the alveolar sacs, red blood cells enter, they have partial pressure of 40, and then this passive diffusion happens because obviously there's higher levels of higher pressure here, so the pressure gradient goes down. So it's kind of like the way that water diffusion goes. It goes from an area of higher concentration to lower concentration. So the alveolar pressure of oxygen is 100, red blood cells enter with 40, and then oxygen enters a red blood cell until it reaches partial pressure of 100. Then pulmonary vein takes its oxygenated blood. Oxygenated blood has a partial pressure of 100. And then it goes back into the systemic system and you start the whole thing again. Okay?